This particular video is the second installment of the solving rational equations kind of lessons. This video is going to deal more with having binomials in the denominator of our fractions. So we're going to have to go through all the different strategies and how to solve this using what we've already done, especially using stuff from the last video into this particular section here. So remember last video we talked about a couple different steps. Okay, we're going to follow those same steps here. So remember the first step was that I wanted to find excluded values. So what I need to do is I need to solve each of these denominators and I'll get excluded values. So the first one where it's n is just equal to 0. Right? I can't solve that any further. The n squared plus 5n, if you look at it, they both contain an n. So I can take that out and I can separate them. So it's n times n plus 5 is equal to 0. And the same with the last one, it's both the n times n plus 5 equals 0. Right? Second and third denominators are the same. So of course they have to factor to be the same thing. So if I said right here n was 0, so that means that this n is also 0. And the same thing here. That's also 0. So we know one of the excluded values is x cannot be 0. Well, because I have an n plus 5, it also has an excluded value there. What number, if I plug in for n in that binomial, will give me 0? That's negative 5. How did I get it? I subtracted 5 to both sides and I got n equals negative 5. So that's my second excluded value. So my answers of the problem, when I solve this whole thing here, my equation here, it cannot be 0 or negative 5. That's where the extraneous solutions come into play. We talked about that last video. If you still don't understand it, again, we're just more practice with it. So step 2 was to then find the LCD of each fraction. So how do I do that? So all I did was take away my equal signs and my zeros and all that stuff that I had there. But again, from previous lessons, I said every time you have a binomial in the denominator, factor first. So I factored n squared plus 5n to get n times n plus 5. And the same thing here. Again, this n cannot be factored anymore. It's a monomial. Remember from, again, previous videos, I need to make sure my denominators are all the same. So what is my common denominator here? Well, both of these, or all three of these actual denominators have the variable n. So this has got an n, that's got an n, and that's got an n. So that means my denominator has to have an n in it. Then I have a binomial and a binomial. Luckily, they're all the same. So that n has to have the same binomial, which is n plus 5. So that's the only difference in this particular equation. And the first fraction, this 1 over n here, actually turns into 1, because of this 1, that was still there, times, what's the difference? N plus 5. Plus 1, because this stays, equals 5, because that stays. You notice I did not change the denominators in this fraction or this fraction. Therefore, the numerators stay. Okay, then the third step, remember, was basically we're saying cross out denominators. I'm going to abbreviate denom as denominator right there. Okay, so cross out denominators and solve. So let's do that. My denominators are gone. What do I have left? I have n plus 5. Really, it's 1 times n plus 5, but that distributive property just makes it n plus 5. Plus the 1 equals 5. And I solve. N plus 6 equals 5, so n equals negative 1. This number doesn't match my excluded values, so I know that my final answer, n is equal to negative 1, is valid. Let's look at this particular problem. Again, we want to find excluded values, but we're tying that in with factoring also. I want to factor if I have a binomial, or if I can factor. this a squared minus a and this a squared minus a are exactly the same. So if I factor one, I'll get the other. What does the first a squared minus a have in common? They both contain an a. Times, what's left if I bring an a out? A minus 1. Then I get a times a minus 1. Remember, they're both the same. And this a minus 1 is just a minus 1. So now I want to find excluded values. I equals 0. So I add 1, a equals 1. So that's my first one. My excluded values are a cannot be 1. Well, what happens then? We know that this cannot be also 1 because 1 minus 1 is 0. This is also 1 because 1 minus 1 is 0. Well, what about this a and this a? It's a monomial. Remember, we've talked about that before. If it's a monomial, it's always 0. So it cannot be 1 or 0. So those are my two excluded values. Those are values that my answer cannot be. So I have my a times a minus 1 in my denominators and then the a minus 1 on the right. What is your common denominator? This is now step 2. Common denominator, if you notice, everything has an a minus 1 in it except for the last one, but I need to add an a. Everything now is exactly the same. So that means this 5 stays, this 1 stays. This 1 here turns into a 1a because I had to multiply the bottom by a, so you have to multiply the top by a. Third step, cross denominators out and solve. 5 equals 1 plus a, or 1a, however you want to write it, minus 1, so a equals 4. This number doesn't match my excluded values, therefore my answer is a equals 4. Go ahead and pause the video to try to solve this one, and then press play once you solve it to see if you are correct. So again, I want to find excluded values. So this x plus 5 over here, I can't do anything with it to factor. But this x squared plus 5x, if we notice, they both contain an x, so I'm pulling that out, so it's x plus 5 is what's left. Then this one here is still x plus 5. Now, hopefully we can kind of do these a little quicker. So my excluded value for the x plus 5s, hopefully again we look at them and we say my excluded value is negative 5. Remember the opposite. So x can't be negative 5. And then for this x here, that's just a 0 because it's a monomial. So my two excluded values are 5 and 0. Now, what do I need? I need a common denominator. The only differences I have is this one contains an x. The last fraction doesn't, and the first fraction doesn't. So I have to add it in there. When I multiply it in the bottom, I have to multiply the top. So 1 times x, x. 4 times x, 4x. This 5 I did not change because my denominator didn't change. Now I solve what's left. X minus 5 equals 4x. Bring that over. That's 3x equals negative 5. Divide by 3. X equals negative 5/3. That number is not an excluded value, therefore you're done. That is the solution to this equation. That concludes this particular video with binomials in the denominator. If I feel that we need more help with this, then I'll throw some more videos up there, but for the most part we should be good to go.